My name is Michel Tielemans, and I would like to welcome you to this webinar introducing our novel product UCECOAT 7999 and focusing on the path towards more sustainable energy-curable resins. Our company allnex developed environmentally friendly product ranges over the last decades and is now driving innovation towards new products from renewable sourcing. Our first Primavera Day at the European Coating Show in 2019 was the occasion to highlight our ABacryl and UCECOAT products that are being produced from biofeedstock. Bio-based polymers can be certified for their renewable carbon content according to the ASTM 6866 standard based on carbon 14 quantification. But another part of our products adhere to the so-called biomass balance approach, indicating that a fraction of biosourced raw materials have been used during the manufacture of the product, but without being able to guarantee the exact amount in each batch. This biomass balance concept is introduced as a viable transition to support the industry conversion to renewable materials and is somewhat similar to the green electricity model used in the energy market. Although the announced depletion of fossil resources will constitute a major industrial challenge in the future, the main value proposition for bio-based coatings today is the material carbon footprint reduction. It is particularly relevant when paired to a substrate that is another biomaterial, either natural, like wood, or synthetic, like a bioplastic. Let's look at the cycles on the left side. The explanation is straightforward. There is a big concern about the massive release of greenhouse gas in the atmosphere, particularly carbon dioxide building up from human transformation of fossil resources. The usage of renewable carbon addresses the cycle imbalance with a neutral carbon footprint proposition, considering that the CO2 released in the atmosphere is coming from the same quantity of CO2 fixation by plants during their photosynthesis. So let's come back a moment to the eco-certification. The renewable carbon content of a biopolymer can be measured after quantification of the carbon 14 in the product according to the dedicated ASTM 6866 standard. This is the explanation. Fossil raw materials contain a negligible percentage of carbon 14 isotope due to radioactive decay, half-time being more than 5,000 years, as opposed to renewable raw materials that incorporate new carbon from carbon dioxide in the atmosphere via photosynthesis and delivering thus a higher and constant percentage of carbon 14 isotope. We can quantify the inherent material carbon footprint reduction from the measured renewable carbon content once translated in CO2 emission savings and expressed in grams per kilo of product. Independent eco-label programs are usually adopted, for instance the OK Biobase 1 to 4 stars rating. Let's take a first example with the novel 100% radiation curable product. Our range has been expanded with a new resin having 30% biocarbon content and providing excellent outdoor resistance for the toughest applications like cladding or siding on the outside of buildings. Xenon weathering proves that it can easily compete with the best aliphatic urethane acrylates available on the market. The name of this product is ABacryl 4690. And this brings us to this straightforward sustainability model for waterborne energy-curable polyurethane dispersions. It has three distinctive axes, as you can see on this triangle. Considering the composition, the product can be made from safe and renewable raw materials with a very low volatile organic content, thus a very strong impact on sustainability. But that's not all. In a second perspective, we need to consider the performance in use. The products have a low film formation temperature and therefore they do not need the use of extra co-solvents in order to make a good film. The trend for high solid content and the use of low energy cure, for instance using LED lamps, can minimize the drying energy. The third dimension is lifetime and disposal. Our coatings offer high durability to extend lifetime of the coated object while providing eventually recyclability or biodegradability. But this brings us really at the front end of innovation. In our journey to pursue a greener and sustainable future, imagine that you can combine the high performance of an energy curable product containing pure water as dispersing medium and renewable polymer as a binder. What would you get? Well, you can stop dreaming. The UCECOAT 7999 is there. It brings a very low volatile organic content with the absence of tin and alkyl phenol ethoxylates. The green polymer contains a minimum of 20% bio-based carbon according to standard ASTM D6866, which corresponds to a significant material carbon footprint reduction. We developed bio-based UCECOAT 7999 with high-end performance suitable for clear and white pigmented coatings. The product is physically drying, meaning there is no tag before cure, and the low minimum film formation temperature does not require additional co-solvents, providing full performance instantaneously after energy cure. So there is no oxidative drying required. It provides a coating with high mechanical and chemical resistance after cure, and the product presents a good colloidal stability with a robust formulation and spray capability, and finally its composition does not contain any tin or alkyl phenol ethoxylates. But what about our technical approach? We considered the building blocks constituting the polymer to address the prioritized substitution from renewable feedstock. It sounds like an evidence that the use of biosourced acrylic acid is prevalent for an easy drop-in. This is the horizontal dashed line marked as 1. But unfortunately, its cost-competitive availability is not expected within the next 5 years. The difficulty was then to assemble a bio-based polyurethane composition with biosourced molecules that preserves a high performance level, meaning a high cross-linking density. The higher the level of bio-based content, the more likely it is to reduce the cured coating hardness, defining an operational zone with a lower hardness envelope that is significantly depressed. Now, let's look at the wet product characteristics of UCECOAT 7999, summarized in the table. They do not provide any bad surprise. The solid content is about 35%, with a pH around 7.5 and a viscosity below 200 millipascal seconds. The mean particle size is typically below 100 nanometers and provides a good colloidal stability, which is above 10 days at 60 degrees. The minimum film formation temperature is below 5 degrees. Due to the low particle size and the presence of renewable raw materials, the product aspect is translucent and yellowish, but this color is of course not visible as a coating. And what about the coating performance? The UCECOAT 7999 was formulated, then applied on the wood substrate and cured with UV light. The two figures present the comparative performance of the UCECOAT 7999, here UV-PUD-1, against the two benchmarks, internal reference 1 and external bio-based reference 2, in clear and white formulations. Left, for the clear coat, the products present a balanced set of properties comprising an excellent adhesion on wood with high gloss, low yellowing after cure, and high hardness with strong chemical resistance. UCECOAT 7999 is very close to the internal benchmark, but outperforms the external benchmark. Right, for the white coat, UCECOAT 7999 presents a good chemical, mechanical and metal mark resistance in comparison with the internal benchmark and is always superior or equal to the external benchmark. It is worth mentioning that the matting of UCECOAT 7999 observed with a specific pigment paste is more effective compared to the two benchmarks and may be advantageous for some applications where no additional matting agents are required anymore. It is now time to wrap up. I hope that we have been able to convince you that allnex is more than ever committed to its pioneering role in radiation curing and anticipates the future market needs by building on sustainable innovation with a novel bio-based energy curable dispersion. UCECOAT 7999 contains over 20% biocarbon, does not require additional co-solvent, and delivers immediate hardness and performance after cure, both in clear and white formulations. allnex is also at the forefront of technology, as exemplified by a new approach to study drying and film formation using near-infrared spectroscopy, results to be published very soon. I want to thank you very much for watching this webinar. Do not hesitate to contact our sales force for any further information on our products. We hope you will read us very soon in the UV+AB Technology Journal. Take care.